This is part 2 of our Introduction to Limits slides. So we'll start by discussing a left-hand limit. And so a left-hand limit occurs when we approach the limit point from the left. And that's read, the limit as x approaches c from the left of f of x is equal to k. Now you should note that this minus sign, which is a superscript for the c, the limit point, indicates that we're approaching from the left, and it does not indicate that the c is negative. Similarly, a right-hand limit occurs when we approach the limit point from the right, and this is read, the limit as x approaches c from the right of f of x is equal to L. Again, that superscript plus sign indicates that we're approaching c from the right. So in order for a limit to exist, the limit from the left and the limit from the right must exist, and they must be equal. So as a theorem, we know that if the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x, and both of those equal to L, then we can say that the limit as x approaches c of f of x is equal to L. If the left and right-hand limits are not the same, then we would say that the limit does not exist. So let's look at an example. Here we have a function. It's a piecewise function. And so let's evaluate the limit as x approaches 2 from the left of f of x. We see as we approach 2 from the left, the functional values are getting closer and closer to 4. Now let's look at the limit as x approaches 2 from the right of f of x. Here we see that as we approach 2 from the right, our limit is getting closer and closer to 2 because our function is getting closer and closer to 2. So in this case, the limit as x approaches 2 of f of x does not exist. Let's look at another example. So let's consider a limit as x approaches 4 from the right of f of x. Here, the functional value at 4 is getting closer and closer to 4. Now let's look at the limit as x approaches 4 from the left of f of x. We see now that this limit is getting closer and closer to 4 as well. So the limit as x approaches 4 from the right and left both equal to 4, and therefore the limit as x approaches 4 of this function is 4. So now let's consider some properties of limits. And so one of them is that the limit of a constant times a function is equal to the constant times the limit of the function. That means that constants times functions, the constants can just be factored out and then multiplied by the limit. The limit of the sum of functions is equal to the sum of the limit of the functions. So let's look at an example. If we consider the limit as x approaches 2 of x plus x squared, this equals to the limit as x approaches 2 of x plus the limit as x approaches 2 of x squared. So we're able to break that sum up and just take the limit of the pieces. Of course, the limit as x approaches 2 of x is just 2. And the limit as x approaches 2 of x squared is 4. So the limit as x approaches 2 of x plus x squared is equal to 6. So let's recap. The limit of a constant times a function of a constant times a limit is equal to the constant times the limit of the function. The limit of the sums or differences of the sums or differences of functions is equal to the sum of functions or differences of the limits of the functions. The limit of the product of the functions is the product of the limits of the functions. The limit of the nth root of a function is the nth root is the limit of that function. The limit of the function. And the limit of the quotient of two functions. And the limit of the quotient of two functions is the quotient of the limit. That the limit of the denominator is not equal to 0 in that limit. Let's look at an example of the constant times functions. Just factor out the constant. The limit as x approaches 1 sums of 3x squared minus x cubed. You can take the limit of each of the pieces and then subtract their limits. Our first rule for evaluating limits is to take the limit of each of the pieces and multiply their limits to the numerator and the denominator. The nth root of a function, which gives us 3 minus 1 plus 1 divided by 1 minus 5. So we are going to evaluate the limit in the numerator and the denominator, and we get minus 3/4. And so here we see that the limit as x approaches c of f of x over g of x was f of c divided by g of c because g of c was not equal to 0.